Welcome to lecture 7.3. So now we have something called double angle formulas. What does that mean? Well, double the angle means twice the angle. So if you'll look at all of these closely, where there usually is x, we actually have something times that x, and it's twice that angle. So we have some formulas for sine, cosine, and tangent. And if you see sine and doubling the angle, you can rewrite it as 2 sine of x times cosine of x. And then for cosine, we actually have 3 different formulas. I'm not going to go into depth on each of them, but these are the 3 different formulas we have for cosine 2x. And then for tangent 2x, we only have one formula, which is 2 tangent of x divided by 1 minus tangent squared x. And you won't have to memorize every single one of the formulas for the next exam. I will give a list of the formulas that will be provided, and I'll give that about a few days before the exam. Okay, but make sure to spend some time recognizing these formulas and working with them. Alright, example 1. Prove sine 2 of x equals 2 sine x cosine of x. Okay, so when we're proving something, once again we start with one side and we move to the other side. So we're going to go ahead and start with the left-hand side. So starting with the left-hand side, sine 2 of x, and we're going to try and prove that it equals this side right here. Well, sine 2 of x is the same as sine of x plus x, right? And we recognize that that is the addition inside of sine. We can rewrite that using our formula, sine x cosine of x plus cosine x sine of x. And if you'll notice, these two are the exact same thing, which means that is equal to 2 sine x cosine of x. And we're done, so we can go ahead and write that, or you could go ahead and write POW or QED. Alright, so example 2. If cosine of x equals negative 3 over 4 and x is in quadrant 2, find sine 2 of x. Alright, so sine 2 of x. Well, we know that sine 2 of x, by our formula we had just earlier, is 2 sine of x cosine of x. Now we already have cosine of x. We know that equals negative 3 over 4. We have that. So what we need is sine of x. Now we do know that cosine and sine are related using one of the identity formulas. So we're going to go ahead and find sine of x using the identity formula, sine squared x plus cosine squared x equals 1. And then solving this, we'll have that sine of x equals plus or minus the square root of 1 minus cosine squared x. Alright, do we know what cosine squared x is? We do, or at least we know what cosine x is. Cosine of x is negative 3/4. We'll go ahead and plug that in. And then we have that sine of x equals plus or minus the square root of 1 minus negative 3/4 squared. We'll go ahead and simplify. Alright, and then we'll get 1 minus 9 over 16. We can create the same denominator, that'll be 16 over 16. So sine of x is going to equal plus or minus the square root of 7 over 16, which we can also simplify to plus or minus the square root of 7 over, and square root of 16 is 4. Okay. We need to figure out which version to take, the positive or the negative. So let's go ahead and look at what we were given. We were given that cosine is negative 3 over 4 and x is in quadrant 2. So quadrant 2, let's see. In quadrant 2, what do we know? We're looking right here. Okay, so sine is positive there, so we'll go ahead and take the positive. Alright, so then sine of 2x is going to equal 2 times, and sine of x we found out was the positive 7 over 4, and cosine of x you already given was negative 3 over 4 from right there. And then let me go ahead and keep this going. And then sine of 2x is going to equal 2 times, and we have the negative 3 and the root 7. Let me just go ahead and rewrite it like this. All over 4 times 4 is 16. Simplifying that, we get negative 3 root 7 over 8. And we are done with sine of 2x. Now example 3, write cosine 4x in terms of sine of x. Okay, so we're going to have to take a look at some of the values we have here to figure this out. Alright, so we're looking at cosine of 2x and seeing if we can replace any of those cosines with some more sines. So what should I use? Well, all of my formulas have to do with cosine of 2x, and I have a 4x, so I need to simplify that. Well, I do know the trick we used last time, that cosine of 4x can be written as cosine of 2x plus 2x. Aha, now we have 2x, which all of our formulas have in it. We can simplify this out using the formula for the addition inside of cosine. So it'll be cosine 2x minus sine 2x, sine 2x. Okay, so let's see. Well, at the moment, we don't even have sine x. Notice we need sine x, not sine of 2x. So we still need to simplify all of these terms to get rid of that 2x inside of them, and also to have them replaced with sine of x. Well, we do know, let me go ahead and write this on the side, that cosine of 2x is also equal to 1 minus 2 sine squared x. I'll go ahead and plug those in here. And we also know that sine squared x is equal to 2 sine x cosine of x. And I'll go ahead and substitute that in here to get rid of any of those 2x. So we'll have 1 minus 2 sine squared x times 1 minus 2 sine squared x minus 2 sine x. Ooh, a lot going on here. Cosine x times 2 sine x cosine x. Alright, so simplifying this out, we'll factor or FOIL these guys together. And what do we get? We get 1 plus 4 sine squared x plus 4 sine to the 4th x minus, multiplying these guys over here together, we'll end up with 4 sine squared x cosine squared x. Now, let's see, what do we have? Well, currently, everything is only just the 1x. The squares are okay, or the fourths are okay. The other thing that we have that we shouldn't have is that cosine squared x. So we're going to go ahead and use the identity for sine and cosine. And replace this. Let's see what we get. So 1 plus 4 sine squared x plus 4 sine to the 4th power of x minus 4 sine squared x times, and let's go ahead and replace cosine squared x with the identity 1 minus sine squared x. Once again, that comes from sine squared x plus cosine squared x equals 1. So that's where we're getting this from. Okay, so next thing, what can we do? Well, we can multiply this in. It will end up with 1 plus 4 sine squared x plus 4 sine to the 4th power x minus 4 sine squared x plus 4 sine to the 4th x. Okay, so everything is written in terms of sine to just the x. We don't have any double angles going on. So now let's just simplify any like terms. What I just realized is I had a sign error here. When I factored out this side, that should have been a negative 4 sine squared x. So let me go ahead and input that. Okay, so do we have any like terms? We do. We have the squares together. And we also have the 4th powers. So let's go ahead and write those in and add them. So we'll have 8 sine to the 4th x minus 8 sine squared x plus 1. And there we go. We've written cosine of 4x in terms of sine x. Okay, so formulas for lowering powers. So now this is different than having a double angle. So if you have sine squared, you can lower the powers, so you'll actually end up getting a double angle, but you won't have a higher power going on. Same for cosine, lower to a double, and tangent, lower to a double. And notice, interestingly, for all of these, for lowering the powers, we all get cosine in our equation. No matter which one we're lowering, they're all going to end up with cosine. In fact, a double angle of cosine. Notice the 2x. Alright, so let's take a look at example 4. Verify the formula. So sine squared x equals 1 minus cosine 2x over 2. Well, we're going to go ahead and use one of the formulas we already know. So we know that cosine 2x equals 1 minus 2 sine squared x. We were given that formula in the very beginning of the video. So let's go ahead and solve for sine squared x. To do that, subtract 1 from both sides, and we'll get cosine 2x minus 1 equals negative 2 sine squared x. Okay, we're trying to get sine squared by itself. So let's divide by the negative 2. And then we'll get cosine squared x minus 1 divided by negative 2 equals sine squared x. This doesn't look exactly like what we have here yet, so how do we manipulate it to look like it? Well, notice the 2 is positive down here. So let's go ahead and multiply the top and bottom of this by negative 1. Now when we do that and distribute that negative 1 inside those parentheses, we'll end up with 1 minus cosine 2x divided by 2 equals sine squared x. And we have verified the formula. Check. Checks out. So now let's take a look at example 5. Write sine to the 4th power x in terms of the first power of cosine. So one thing also to really note, remember, sine 4x is not the same as sine 4x. This is talking about having sine to the x to the 4th power. This one is fourthing the angle inside of x. Okay, so remember to bear that in mind. Alright, so we're trying to write sine to the 4th power in terms of the first power of cosine. What do we know about sine to the 4th power? Well, it is actually the same thing as sine squared of x squared. Now, why would I do that? Well, because I do know formulas for sine to the 2nd power. So if I can simplify things into formulas, I know I'm in luck. Well, remember, sine squared of x is equal to 1 minus cosine 2x divided by 2, which then means that I can just go ahead and square both sides for the formula. Okay, so we can go ahead and distribute that 2 to top and bottom, and we'll get 1 minus cosine 2x squared all over 2 squared, which would be 4. Okay, so multiplying out the top, we'll end up with 1 minus 2 cosine of 2x plus cosine squared x. Cosine squared 2x divided by 4. Alright, let's go ahead and break up this fraction. And then we'll have a 4th minus cosine 2x over 2. I simplified the 2 and the 4 there. And then plus cosine squared 2x divided by 4. Nothing to simplify there. Can I use this to simplify anything else? I know I can simplify cosine squared of 2x with one of our formulas. Let's go ahead and plug that in. So we'll have a 4th minus, and I'll pull the half out from the cosine 2x, cosine 2x, plus, we'll have that 4th times, and cosine squared of 2x we know equals 1 plus cosine 4x divided by 2. Alright, we can go ahead and continue writing this. We'll get a 4th minus half cosine 2x plus, and distributing that 4, we'll have 1/8 plus an 1/8 cosine of 4x. Alright, can we simplify any of these? Well, we can combine the like terms of the fractions right here. And the cosines, these two are different terms, so we cannot combine these. And our answer will be, so 4th plus an 1/8 is going to be 3/8 minus a half cosine 2x plus 1/8 cosine of 4x. And notice all the powers of cosine are 1. We don't worry that they have double angles or 4th angles, not 4 times angles. We're just worrying that they are the first power of cosine. So we have completed that task, and there we go, is our answer. Now we have a new formula. Once again, there are a ton of formulas, so you will be provided with some of the formulas for the exam. So we have something called half-angle formulas. What does that mean? Well, basically, if what you have inside here is half of an angle that you might know. Okay, Okay, and these are the formulas for them. They involve square roots for sine and cosine, and then tangent is these formulas. Once again, I'm not going to go into too much detail for those, but please spend some time taking a look at those. And the choice of positive or negative depends on the quadrant in which our half angle is in. Okay, so we're going to go ahead and verify the formula of sine u divided by 2 equals plus or minus the square root of 1 minus cosine u over 2. Well, what do we know? So we know, using a previous formula, that sine squared of x is equal to 1 minus cosine 2x divided by 2. So notice, here we have sine to the 1 power. So let's go ahead and square root both sides. And we'll end up with sine of x equals plus or minus the square root of 1 minus cosine 2x divided by 2. Now we're almost there. It looks really, really close. The only difference here is we have a u divided by 2 and a u, whereas in our problem now, we have an x and a 2x. So let's use a substitution here. Let's let x equal u divided by 2. So when I do that, we get u divided by 2, and here we have 2 times u divided by 2. So those will cancel out. And then we have sine of u divided by 2 equals plus or minus the square root of 1 minus cosine of u divided by 2. And there we go, we have verified the formula. That is exactly what we had here. Alright, let's take a look at example 7. Find the exact value of cosine 22.5 degrees. Alright, so usually the value inside of cosine is something that we know, but right now it is not something we know, so we need to use different methods to solve for this. Well, one, because we were just given information for half angle formulas, and also we try to use the information, is this half of an angle that we know? 22.5. And the thing is, yes it is. So 22.5 is half of 45 degrees. So we're going to go ahead and say let u equal 45 degrees. Let me go ahead and write down the formula we're going to use first. So we're going to say let u equal 45 degrees, and recall that the formula is cosine of u divided by 2 equals the square root of 1 plus cosine of u divided by 2. Positive or negative. Okay, so let's go ahead and solve this. So cosine of 22.5 is the same thing as cosine of 45 divided by 2, which will equal the square root of 1 plus cosine 45 degrees divided by 2. And what is cosine of 45 degrees? Cosine of 45 degrees is square root 2 over 2. So we'll get the square root of 1 plus root 2 divided by 2 all over 2. Simplifying this, we'll end up with the square root of 2 plus square root of 2 divided by 4. And then lastly, simplifying that, we get the square root of 2 plus the square root of 2 divided by 2. Lots of 2's. Alright, so there we go. So if you notice that the angle inside of the cosine, or whatever trig function you have, is half of one of the known angles, you can use the half angle formulas to solve for it. So it makes it a lot simpler. Now, for example 8, find tangent of u divided by 2 if sine of u equals a fifth, where we have that u is in between 90 degrees and 180 degrees. So real quick, let's make a sketch of that. Where is u? Between 90 and 180, which would be right in here. Well, we know by the formula that tangent of u divided by 2 is equal to, now there are two options, but we'll go ahead and use the first one, 1 minus cosine of u divided by sine of u. So we're trying to find this, and we are given sine of u, which is a fifth, but we don't have cosine of u. So we need to try to figure out how to find cosine of u. Well, we're going to go ahead and use that really handy identity formula, which always pretty much comes in handy. So cosine squared u plus sine squared u is equal to 1. We know this by the identities. And solving, like we do quite a bit, we'll have that cosine of u equals the square root, plus or minus, 1 minus sine squared of u. So the question is, which one should we take? Well, since we're in quadrant 2, cosine is negative here, so we're going to go ahead and take the negative. So cosine of u is going to equal negative square root of 1 minus sine squared u. However, we know sine squared of u equals a fifth. So let's go ahead and plug that in. And we'll get cosine of u equals negative square root of 25 over 25. I just changed the 1. Minus 1 over 25. And then we get cosine of u equals negative, and simplifying this, 2 root 6 over 5. Okay, once again, if you ever need any side work for doing any of these simplifying processes, these are from Math 103 or 135, just please let me know, and I can give you some resources to remember how to simplify with radicals. Alright, so we have found cosine of u. Huzzah! Cosine of u is negative 2 root 6 over 5. Let's plug that into our equation. So now we have 1 minus negative 2 root 6 divided by 5 over sine of u, which is 1 divided by 5. Now we can go ahead to simplify those fractions with the 5. We'll multiply top and bottom by 5, and we will get 5 plus 2 root 6. So there we have it. Tangent of u over 2 equals this. And as usual, and I think I've mentioned it before, but this formula, or this identity right here, is often one of the most used ones, so definitely good to have that one memorized if you don't already have it memorized. Now let's take a look at example 9. Write sine 2 tangent inverse of x as an algebraic expression in x. What does that mean? Well, basically, we want to rewrite that where we only have x, so no trig functions inside of it. So let's see. So we have sine of 2 tangent inverse of x. We want to write this without any of the trig functions. So to simplify this, let's first take a look at this without that inside amount. So let's say let tangent inverse of x equal theta. So we can simplify this. So then that means that we get sine of 2 theta, which looks way easier to work with. Once again, substitution really helps to simplify things. So sine of 2 theta, we know that, and we can simplify that into 2 sine of theta cosine of theta. But we're not that much closer to writing our expression in terms of x. Let's go ahead and try draw up a right triangle. So since tangent inverse of x equals theta, we know that tangent of theta must equal x. So if I drop a right triangle, and we have our degree theta, tangent, remember, is opposite over adjacent, which means this is x over 1. So opposite should be our x value, right here, and adjacent would be our 1 value. Let's go ahead and plop those in, 1 and x. And then to find the hypotenuse, I'm going to go ahead and do this on the side. Sorry for the small amount of space here. Our hypotenuse squared is going to equal the 2 sides squared. So solving for our hypotenuse, h is going to equal the square root plus or minus x squared plus 1. We're going to take the positive version, and we have that this side must equal x squared plus 1. Okay, so we figured out our triangle. The next question is, can we find sine and cosine from that triangle? The answer is yes, we can. Remember, sine is, if we're looking at SOHCAHTOA, sine is opposite over hypotenuse, which means it's going to be x over square root of x squared plus 1. And cosine is adjacent over hypotenuse, so that'll be 1 over square root of x squared plus 1. Okay, so multiplying this together, we get 2x over x squared plus 1. And we are done. Alright, so definitely the simplifying with the u sub, or just with the substitution, did help. Okay. And once again, for dropping the triangle, if you ever have one of the functions and you're trying to find the other two, dropping a triangle really helps because we know how to solve for the other values. One reason why we drop the triangle. Okay, so the next of the many formulas that we have in trig, the product to sum formulas. What does that mean? Well, what it means is if we have a product, we can find a way to rewrite it in terms of a sum. And product, if you recall, is multiplication, and sum means addition. So we can write a multiplication problem in terms of addition, which you'll notice here. We have the multiplications, and then we can rewrite them in terms of additions, or actually subtractions. And these are all just for multiplication between sine and cosine. Alright, so let's take a look at an example. Example 10. Write the product as a sum. So at the moment, it is what? It is a product because we have multiplication going on. So which one does this fit? We have sine times cosine. So sine times cosine, right here, we'll use the first one. So what will our u and v values be? Well, u we'll have right there, and then v we've got right there. So let's go ahead and rewrite this. Oops, sorry, let me color code this. We have this was our v value, and this is our u value. Okay, so that's going to equal half sine of 2x plus 3x plus sine of our u value 2x minus v 3x. Let me go ahead and color code this as well, so we can see the values. And there we go. Okay, so simplifying, we'll end up with half sine of 5x plus sine of 2x minus 3x is going to end up giving us a negative x. Then we have half of, so sine of 5x. Oh, and see that negative inside the sine of x. So the question is sine an even or an odd function? Well, sine is the odd, which means that negative gets pulled out. So we have minus sine of x. And then lastly, we can go ahead and distribute that half to all of them, and we get half sine of 5x minus half sine of x. Okay, so now we're going to have sum to product formula, so the exact reverse direction. If we're given a sum and we want to rewrite it as a product, this is what we can do. So sine, so notice these are all products, addition or subtraction, and we can rewrite them in terms of some form of multiplication. Huge formulas, these will be given to you for your exam. Once again, I will provide a list of the items that will be given to you. Okay, so write the sum as a product. Well, let's see. Which one of these are we given? We have sine and sine, and it's an addition sine and sine. So addition of sine and sine is the first one. Now let's go ahead and identify, so this is our x and, oops, wrong color, our y. So x goes here, and y goes there. All right, let's go ahead and plug this in. So we have 2 sine of 5x plus 3x divided by 2 times cosine of 5x minus 3x divided by 2. Okay, real quick, color coding. All right, so let's simplify further. Now we have 2 sine, and all the x values will add up, so we'll get 8x divided by 2. Cosine of, subtracting, we get 2x divided by 2. Can we do any other simplifying? Yes, we can. We can simplify the fractions in here. And then we'll get 2 sine of 4x, cosine of x. Now you don't actually have to write these guys here in parentheses. I usually just do if the expression is getting rather complicated, just so I don't confuse myself. So usually I'll write the parentheses there, so that you don't think, for accident maybe, that this is a 2 sine 4 times x times cosine times x. Very different. So usually I'll go ahead and write the value that's inside the functions for sine and cosine inside of parentheses, especially if they're more than just x. Alrighty, that is it for 7.3. Please email me if you need any help with any of the problems.